Today we're going to talk about properties of logarithms. By the end of this video, you should be able to convert between exponential and logarithmic form, and you should be able to expand and condense logarithms. So, we talked about logarithms briefly a couple units ago when we graphed exponentials and logs. Now we're going to go back and we're going to talk about some properties of logs and how to solve exponential and logarithmic equations. Today we're just going to focus on the properties. So, consider the following equations and solve for x. 2 to the x power equals 4. You should know that 2 squared gives you 4. So, x equals 2. You should know that 2 to the third power gives you 8. So for the second equation, x equals 3. Now what about 2 to the x power equals 6? X is going to have to be a decimal for that to be true, which is why we have logarithms. So the definition of a logarithm with base b, remember that the base is the subscript, and y has to be positive because if you remember from when we graphed, the domain of a logarithmic function was from 0 to infinity, and b cannot equal 1, so the base cannot be 1. If we have log base b of y equals x, that is the same thing as b to the x power equals y. So a logarithm always equals the exponent. Let's look at a couple of examples of this. Now, we have two different types of logarithms on your calculator. The common log is log base 10. And typically, you don't write the base for that. You just write log of x. So if you look at your calculator, the log button on the side is the common log, or log base 10. The natural logarithm is log base e. E is an irrational constant, similar to pi, and log base e is abbreviated natural log, or ln. So this ln button, right under the log button, is the natural log. Now we're going to rewrite the following equations in exponential form. So if we have log base 4 of 64 equals 3, remember that the base of the logarithm is always the same as the base of the exponential. So we have 4, and then the logarithm always equals the exponent. So 3 will be our exponent, and that equals 64. And this should give you a true statement. So you can always double check that you converted correctly by typing 4 cubed into the calculator or by looking at your power sheet if you still have your power sheet. For the second one, we have log base 5 of 125 equals 3. So our base will still be 5. Remember that the logarithm equals the exponent. So we have 5 to the third power equals 125. And for the third one, log base 7 of 1 equals 0. The base will stay the same. The logarithm always equals the exponent. So we have 7 to the 0 power equals 1. Now let's try it the other way. Rewrite the following expressions or equations in logarithmic form. So we have 3 to the 4th power equals 81. So we have log, and then the base will be the same as the base of the exponent. We know it equals the exponent. So we have log base 3 of 81 equals 4. For number 5, we have 2 to the 5th power equals 32. So we have log base 2 of 32 equals 5. And for the 6th one, 4 to the 3rd power equals 64. We already did this one. Log base 4 of 64 equals 3. Now let's look at the meaning of a logarithm. What does log base 4 of 256 mean? That means 4 to what power equals 256? Or 4 to the x equals 256, and you would figure out what x equals. So we're going to evaluate these logarithms without a calculator. But you can use your power sheet if you still have that. So log base 3 of 243 means 3 to what power equals 243? If you look at your power sheet, 3 to the 5th equals 243. So this would mean x equals 5, or we could just say that this expression equals 5. Log base 2 of 2 means 2 to what power equals 2? Well, that would be 1. Log base 5 of 1, that means 5 to what power gives us 1? Well, hopefully you remember that anything to the 0 power equals 1. Log base 4 of negative 2, that means 4 to what power equals negative 2? There's no number that you can plug in for x that will give you negative 2. Because, if you remember, the domain of a logarithmic function was 0 to infinity, so you cannot do log of a negative number. So this is not defined. And the last one, log base 1/3 of 81, 1/3 to what power equals 81? This is a little bit tricky. If we look at our power sheet, we know that 3 to the 4th power gives us 81, but we have 1/3. Hopefully you remember that negative exponents mean you take the reciprocal of the number. So this would actually be 1/3 to the 4th power would give us 81. So this would equal negative 4. Now, you can evaluate these in the calculator. We talked about this earlier in the year. If you go to Math, Log Base, you can type these problems in. Whoops. And we get negative 4. So let's look at some properties. First, we have the product property. And all of these properties are related to the properties of exponents. So hopefully you remember that if you have a to the n power times a to the m power, you add the exponents and you get a to the n plus m power. So since logarithms always equal the exponent of an exponential, logarithmic properties are related to properties of exponents. So the product property says if you have log base b of u times v, you can expand that to be log base b of u plus log base b of v. So if I have log base 3 of 9 times x, I can split that up into log base 3 of 9 plus log base 3 of x. And then I can simplify this a little bit more because I can evaluate log base 3 of 9. This means 3 to what power gives me 9? This would be 2. We can also condense these. Whenever you see the direction to condense, you want to rewrite it as one logarithm. So if I have log base 2 of x plus log base 2 of 7, I can rewrite that as log base 2 of 7 times x. Now, expanding and condensing logs seems like a silly exercise right now, but they do have purposes. When we get to solving exponentials and logs in the next couple days, you will need to expand and condense logs to make the problems easier. If you get to calculus and you're trying to take the derivative or the integral of a logarithm, expanding or condensing that logarithm could make it easier or harder. The next property is the quotient property. So hopefully you remember from Algebra 1 that when you have a to the n divided by a to the m, you subtract the exponents and get a to the n minus m. So again, the logarithm properties are related to the properties of exponents. So if we have log base b of u over v, we can rewrite that as log base b of u minus log base b of v. So if we're going to expand log of 2/7, since there's no base written here, the base would be 10, so this is the common log. But we can rewrite this as log of 2 minus log of 7. And that's it. We can't evaluate any of those because we would be asking 10 to what power gives us 2 or 10 to what power gives us 7, and those are not easy to compute. If we are going to condense these logs, we have natural log of x minus natural log of 3. We can rewrite that as natural log of x over 3. I typically write natural log in cursive letters so that the L does not get mistaken for an I or a 1. And then the next property is the power property. If you think back to Algebra 1, we had this property that a to the n to the m equals a to the nm. So again, our property of logarithms is related to the property of exponents. If we have log base b of u to the n, we can rewrite that as n times log base b of u. So if I want to expand log base 3 of x to the 5th, I can bring the exponent out front and have 5 times log base 3 of x. And then if I want to condense, I have 3 times log base 2 of 3. I would bring the number that's out front up to be the exponent. So I would have log base 2 of 3 cubed. And 3 cubed is 27, so I can write this as log base 2 of 27. Now, most problems that involve expanding and condensing logs use multiple properties. So if I want to expand log base 4 of 64x over y to the 5th, think about your order of operations as you're doing this. I'm going to first split up this fraction so that I have a subtraction problem. Then I can split up each of these terms farther. I can split up log base 4 of 64x into log base 4 of 64 plus log base 4 of x. And then I can rewrite log base 4 of y to the 5th as 5 log base 4 of y. Now, I'm not quite done because I can evaluate log base 4 of 64 because 4 to the 3rd power gives me 64. So this would just be 3 plus log base 4 of x minus 5 log base 4 of y. Now, if I am going to condense this next expression, first I want to deal with the power property. So I want to move all of these numbers that are out front to be my exponents. So I have log base 5 of x cubed minus log base 5 of y squared plus log base 5 of z to the 6th. Now, here's where you have to be careful. You are only subtracting log base 5 of y squared. So when I go to use the product or quotient property, log base 5 of y squared is the only thing that is being subtracted. The other two terms are positive. So I would have log base 5 of x cubed z to the 6th over y squared. Because log base 5 of y squared is the only term that is being subtracted, so y squared is the only term that will be in the denominator of the fraction.